A warm welcome to all the viewers of this video. We are here with the presentation on comparative study of different CPU scheduling algorithm which comes under the course operating system. Let's have the introduction about us. We are the students of class TYCMSS semester 5th. Our names are Akshata Bidwe, Shubhangi Thorat and me Vedant Sawant. Our project is guided by Mrs. S.R. Bhadguzer ma'am. Further, I request Shubhangi to speak ahead.
Let's see contents of our presentation. First, we will understand what is scheduling, then preemptive and non-preemptive scheduling will be discussed. Then five types scheduling algorithm that are first come, first serve, shortest job first, shortest remaining time, round robin, priority scheduling. At the end, we will see the conclusion of our presentation. So let's see what is scheduling. CPU scheduling is basically scheduling a process to maintain multitasking and keeping the system performance high. As you can see in the diagram, there are three types of schedulers. The long-term scheduler beside ready queue determines which process are to be admitted. Next is short-term scheduler, which selects processes that are ready to execute and allocate CPU. And the mid-term scheduler beside waiting queue removes the process from memory for later use. Preemptive and non-preemptive scheduling. In preemptive scheduling, a running process gets interrupted by high priority process. In non-preemptive scheduling, once CPU has been allocated to a process, the process keeps the CPU until it releases the CPU either by terminating or by switching to the waiting state. Now let's get started with different scheduling algorithm. First algorithm is first come first serve, which is non-preemptive. In this algorithm, CPU is assigned to the process which requests first. Let's understand this with the help of example. Here in this example, P1, P2, P3, P4, 5 P5 arrive at the same time in the same sequence with burst time as 10, 1, 2, 1, 5 respectively. From this burst time, let's have Gantt chart. We know that the process which requests first gets executed first. So here P1 will get executed first with the burst time at 10 milliseconds. Next process P2 will start its execution at time 10 milliseconds. It has finished its execution as 11 milliseconds. It has burst time 1 millisecond. Similarly, process P3, P4, P5 will get executed with burst time 215 respectively. Now let's have waiting time. Is the time required waiting for its execution? Turnaround time, which is completion time. So the process P1 started at 0. So its waiting time will be 0 and completed its execution at 10 milliseconds. So its turnaround time will be 10. This will same for process P3, P4, P5. So the from this average waiting time will be addition of all the process divided by number process, which gives 9.6 millisecond as waiting time and 13.4 millisecond as turnaround time. Now I nominate Akshata to explain further.
Thank you, Shubhangi. Next algorithm is shortest job first, that is non-preemptive algorithm. This algorithm states that the process that has smallest burst time will be executed first. Let's understand this algorithm with the help of example. This processes as same burst time from earlier example which was told by Shubhangi. So let's have Gantt chart of these processes with the help of example. As we know that the process which has smallest burst time gets executed first. So in this case, process P2 has smallest burst time, so it will get executed first. Next process, that is P4, has lesser burst time, so it will get executed after P2. Similarly, P3, P5, P1 will get executed accordingly by their burst time. So let's have turnaround time and waiting time of these processes. As we know that turnaround time is the time of submission of process to the completion of process, and waiting time is the how much time processes spend in the ready queue waiting their turn to get on the CPU. Processes P1 Process P1 is completed its execution at 19 milliseconds, so the turnaround time is 19. As you can see in the Gantt chart, process P1 started its execution at 9 milliseconds, so the waiting time of the process P1 is 9 milliseconds. Similarly, process P2 is completed its execution at 1 millisecond and waited for 0 milliseconds. Correspondingly, process P4 and P5 have their turnaround time and waiting time as 1249 respectively. By this, we can calculate the average of waiting time as 3.2 milliseconds and turnaround time as 7 milliseconds. Now, next algorithm is remaining time next, which is SJF preemptive, which states that the process that is closest to completion gets executed first. Now let's see example for this algorithm. You can see 5 processes with their arrival time. Here, arrival time is the time on which process has arrived with the burst time as 10:12:15. Let's have the Gantt chart. We know that let's have Gantt chart. We know that the process P1 has arrived first at 0 millisecond, so it will start its execution first. But here process P2 arrived at 1 millisecond, so it will start its execution back, interrupting execution of P1. Next P5 will arrive at the time 2 millisecond. So we so again it will interrupt the execution of process P2 and start its execution. Next process at arrival time of 3 milliseconds will arrive the process P3 has less burst time as compared to other, so it will complete its execution. Then P4, P5 and P1 will execute accordingly. Now, if we talk about turnaround time and waiting time of these processes, for process P1, the turnaround time will be completion time minus arrival time, that is 19 minus 0 and is equal to 19, and turn waiting time as turnaround time minus burst time, that is 9. Similarly, waiting time for P2, P3, P4 and P5 will be 0013 and turnaround time as 1228 respectively. If we calculate average waiting time, it will be 2.6 millisecond and turnaround time as 6.4 millisecond. Over to you, Veda.
The next algorithm comes, that is priority scheduling, which states that the highest priority process will get executed first. This type of algorithm is non-preemptive algorithm. Let's discuss example of the same. Here we have to consider lowest number as the highest priority. So the process P1 has priority 3 with burst time as 10. Process P2 has priority 1 with burst time as 1. Process P3 with priority 3 and burst time as 2. Similarly for P4 and P5 respectively. Now let's draw a Gantt chart for the same. As we know that the highest priority process will get executed first. So from the table, we can conclude that process P2 has highest priority, that is 1. So it will start its execution. Next process P5 has priority 2. So it will start its execution and it will end up with the burst time as 6. And then process P1 will start its execution as it has free priority. Similarly, these processes will start its execution according to their priorities. If we talk about waiting and turnaround time, then we know that the waiting time is the starting time. So process P1 started at 6 milliseconds, so it has the waiting time as 6. And the turnaround time, that is completion time, will be 16 as usual for process P1. This will be the same for process P2, P3, P4, P5 as they have started with their respective times and ended at their respective times. If we calculate the average waiting time and turnaround time, then it will be 12 millisecond for waiting time and it will be 8.2 millisecond for turnaround time. Now let's have the last algorithm, that is round robin, which state that each process will execute after a specific time quantum. Let I tell you the time quantum. The time quantum is a small amount of time which gets which gets executed after the process. So every process will get executed for one time quantum. Let's understand this with Gantt chart and the example. So every process will execute for 1 millisecond, though it has a higher burst time. If we look at the Gantt chart, process P1 has 10 burst time, but it has executed up to one time quantum. Similarly, process P1, P2, P3, P4, P5 will execute simultaneously with 1 millisecond by interrupting each other. And then again, execution of process P1 will start for 1 millisecond itself. This will continue till the last process of burst time execution. Now let's see the waiting time and turnaround time for the same. Process P1 has waiting time as 9. As usual, the starting of the waiting time and the ending of the process is 19, that is turnaround time. This will be same that P2 will start its execution at 1 and it end its execution at 2. Process P3 will start its execution at 5 and end its execution at 7. Process P4 will start its execution at 1 and end its execution at 4. Here we have to remember that the last process is to be taken while calculating the waiting time. And the average of waiting time is 5 milliseconds and the turnaround time will be 7.2 milliseconds. That's all about algorithms. Let's have the conclusion of the presentation. Here in this table, we have mentioned all the solutions of the same example which we have discussed. The average waiting time and the average turnaround time are in the table. We can conclude that the average waiting time with turnaround time is not same for every algorithm. It depends upon the arrival of process, priority of process, and how long it takes to complete its execution. So you might be wondering of a question, which scheduling algorithm can be best? So sometimes FCFS algorithm is better than the other in short burst time, while round robin is better for multiple processes in every single time. However, it cannot be usually predicted as we are not able to know the burst time. If we know the burst time, then credit for the scheduling algorithm can be given and we can choose the best scheduling algorithm. This data is from web source. That's all about presentation. Thank you so much for watching the video.